Okay, so our next main goal, which is a key point here, is to show that we have a nice algebraic structure when we are looking at paths up to homotopy and the operations on them up to homotopy. Okay, so I don't want to be specific what algebraic structure will be soon enough, but essentially we have associativity, identity, and such properties. Okay, so for example, let's just take a space here as usual, and we'll have various paths. Let's take a path alpha. It begins at some point P and it ends at some point Q, and then I want a path which is going to be, so what we know is we have a sort of identity EP which is constant at P. Okay, let's call this part A. EP star alpha is homotopic to alpha, and similarly alpha star EQ is homotopic to alpha. Okay, so that EPs and EQs act like identities. Yeah, so we'll see groupoids where you have lots of identities but rather than one, and when we specialize, as I said, to loops, you'll get just one identity. So the key point is, why is this true? And we'll look at B first because the picture is a little bit simpler. So what we are going to do is we are going to define a function, and that function is going to be, when I look at this square, so I'll take a square, and I'm going to define the function by cases. That should not at all be surprising because after all the star is also defined by cases. At the bottom we have alpha on the first half and E on the top, and on top we just have alpha right through. So what we'll do is somewhere in between we will still have alpha here but at an appropriate speed, and we will still have E here. I should say EQ to be explicit. Okay, so we figure out what this division is. So what happens is at base we are going at double speed, then we slowly slow down a bit till at the top we are going at just single speed, and for less and less time is left, so for less and less time we are constant. Okay, so let's define this homotopy. We want to define H from 0 1 cross 0 1 to X, and since this is the first such instance, we'll see a bunch of cases where we do such things. I'll be rather explicit in figuring out, for example, what that line is. Okay, so let's try to figure out what this line is. This line here is given by something of the form is S equals AT plus B. So this region is going to be S is less than or equal to AT plus B. And so what are A and B? Well, when T is 0, so when T is 0, so S equals half. It's going to be the midpoint. So this implies when T is 0, S equals half. This just implies B is half. And when T is 1, S is going to be 1. This implies now that we have A into 1 plus half is 1. Okay, so this implies A is half. So S is going to be 1 plus T by 2. Now you could by inspection tell this, and we will frequently write this down, and when you write such a formula, remember it's a line. So a line is determined by its value at 2 points. So if you guess a formula, simply have to verify that it's correct at 2 points, then you're fine. Okay, so what is this? This is dividing into two regions. It's dividing into a region where we have alpha and where we have, let's make EPs orange. So we have the alpha region and then the region which is not alpha. Okay, so H of S comma T is going to be something when S is less than or equal to 1 plus T by 2, and something else when S is greater than or equal to 1 plus T by 2. Okay, actually I should say 1 is greater than or equal to, and here 0 is less than or equal to. Okay, so this is the way in which we can divide the regions, and they have to agree on the boundary. Okay, what is it when it's greater than or equal to? That's kind of trivial. That's Q. So this orange region is Q. What about here? It's alpha at a certain speed, and let's figure out what that speed is. Again, you could just inspect and guess, but since this is the first time, I'll do this rather explicitly. So in this case, what is the speed? Well, suppose we want it to be, suppose we want over there a function of the form alpha c times s. Okay, where what we know is that when we reach this end point, this point remember is 1 plus T by 2. when we reach this end point, we want to reach 1. So what we know is alpha times c into 1 plus t by 2 is alpha of 1. And since alpha is arbitrary, the only way we can ensure this is, so strictly speaking it's implied by, but really the only way we can ensure this is to take c is going to be 2 over 1 plus t. Okay, that's so that the reciprocal of 1. This of course you should expect. So what speed is going to be reciprocal of the distance time taken. You can think of this as the time taken, and we always have to travel the distance 1. So here we have the formula alpha of 2s by 1 plus t. Now it's routine to verify that on the line both of these is going to be alpha of 1, which is q. So these two will agree, and hence we actually have a continuous function. A warning, you can write all sorts of such formulas and prove basically anything, whether it's true or false, if you don't verify continuity. So the formulas are just there. Okay, and again, how do we write the formulas? Well, they are just linear functions. So one would have learned long ago how to handle linear functions, but typically all you have to do is, you can do usually, is guess and verify. Okay, so this gives us the first of our results. Now then we'll have to look at a bunch of other such things, including A and associativity and the inverse. Okay, so first we'll go on to, so here is A once more, which we'll had stated earlier. I did B because the picture was a little bit similar. So recall that this is trying to say EP star alpha is homotopic to alpha. And not surprisingly, we will get a similar picture, a square. Okay, so let me take a slightly more erect square. And again I have to draw a line. So let's, this time it's going to be EP star alpha, so it will go this way. Okay. Oh, I'm sorry. It goes this way because on top I want EP. So what we have here is EP and alpha, and here we have alpha. The what I call purple colored region was this way. Okay, now we need to know two quantities. I'm going to skip a couple of steps. If they're not clear as an exercise, you can just do them by brutally writing down the lines. So what is this line here? Okay, so this line is actually S equals, instead of 1 plus t by 2, it's 1 minus t by 2. How do we check that? At t equals 0, it's still half. At t equals 1, it became 1 minus 1 by 2, which is 0. So this is the line. So you negative slope and slope minus half. So you could just guess that from the previous one, or you could solve the linear equations. But there is another thing we need to know here, which is important. What is the length of this guy? Because our speed is going to be determined by that, right? So the length of this guy is that what we had last time. This is 1 plus t by 2. So speed is going to be the reciprocal of 1 plus t by 2. Okay. So I put these aside for a moment. So what is our formula going to be? H of st. Let's split into cases. The first case, let me write it cleaner this time. 0 is less than or equal to s is less than or equal to 1 minus t by 2. And the second case is going to be 1 minus t by 2 is less than or equal to s is less than or equal to 1. And now the first case here is just EP. And the second case is alpha of something. Okay, now let's try to figure out what that something is. First of all, like with our beta of 2s minus 1 that we had, we have to look at the distance between this and this point. Okay, so what I look at is s minus this point is 1 minus t by 2. Okay, it's getting a little ugly there. Okay, so what I'll write it here and then we'll copy it there. So what I look at is alpha of, so first of all I look at the difference s minus 1 minus t by 2. Why is that? Because that is the quantity which tells you the difference between this and the left end point. So when s is 1 minus t by 2, I want alpha of 0. But now I also want to change it by the speed. Okay, and the way I change it by the speed, remember the speed is going to be 2 over 1 plus t. Okay, so let's get rid of these 2's. So this is going to be alpha of 2s minus 1 minus t. So this is going to be 2s minus 1 plus t, and I divide it by just 1 plus t. Okay, so let's take it as 2s minus 1 plus t divided by 1 plus t. As I said, if these formulas look magical, they're not. You're just saying we are finding piecewise linear functions. So for that you have to divide pieces, and the pieces are also linear. So you have to find the lines that divide the region, and then you have to scale but also shift base point. Okay, so you want a function with properties determined by the endpoint. Okay, so this is this gives the required homotopy, gives a homotopy. Between EP star alpha and alpha. Okay, so what? Now our next theorem, we'll continue along this line. This one is a little bit harder. Okay, so it's no need of A and B because bar is symmetric. I'll just say alpha star alpha bar is homotopic to so let's check where it begins and ends at P. So we have the same setup as before. Alpha star alpha bar begins and ends at P. This is a slightly more interesting picture here as well. I mean in the actual surface, and the construction is a bit different. So we have P here, we have Q here. And what is alpha? It may be a curve that goes this way, and alpha bar just comes back. Okay, I'm drawing it next to it because it would not be visible otherwise. It just comes back from here to here. So we have alpha star alpha bar is going to be equal to P. So at time 0 we are going all the way to Q and coming back. What should we do at time t? Well, at time 1 we want to just wait at P. Okay, so there are a couple of different options. The option I'll choose is we'll travel at the same speed as we did for a little while. So let's say at time half we have covered half our distance, then we'll just stop. We'll wait there and then we'll reverse and come back. Okay, the other option would be to change our speed, or another option, but we'll take this thing here. Okay, so what I'm going to do is I'm going to write down, draw a picture under this, and then we'll write down the cases accordingly. Okay, so let's get some straight lines. So here we are. Here's a rectangle. Okay, so remember we have to have, so I'll draw the lines here and then we'll see why we have these lines. Okay, so remember now our situation is a bit different. Here we have alpha and here we have alpha bar. Okay, so let's repair this. It goes up to there, and here we just have EP. So it's a single piece on top. So what we'll do is that we'll go here at constant speed, but the same speed as we did previously. So we end up at this point. This point is going to be alpha of, actually we know what this point is. This is 1 minus t by 2. Okay, and then in between these two, I'll keep my purple. Oh, I didn't like my selecting purple. In between these two, this is going to be E, but I will fill up what it is, the identity of. It's the identity of these guys. And meanwhile, this part I'm going to just take alpha. So this point, so here it's just going to be alpha of S. Okay. And this point, well, alpha bar is alpha reversed. So I could just say it's alpha of 1 minus S. Here. Okay, so at the base it's going to be this, and now this side is going to be, remember this thing is S equals 1 plus t by 2. Okay, so alpha of, on the line we are going to get alpha of 1 minus 1 plus t by 2, which is going to be alpha of 1 minus t by 2. which is indeed what we have on the left hand side. Okay, so again we'll look at the picture once more once we write the formula. There are going to be three pieces here. The first piece is going to be from 0 to 1 minus t by 2. The second piece is going to be when s is between 1 minus t whole 1 minus t, the whole thing divided by 2. This is less than going to s is less than 1 plus t by 2. Okay, and the final piece is when 1 plus t by 2 is less than s is less than 1. Here, as I said, we are just going to be alpha of s. Okay, and here this is going to be alpha of 1 minus s, which is in other words the same thing as alpha bar of s. So it coincides with alpha bar. And what about in the middle? In the middle I'm going to take alpha of 1 minus t by 2. But that also happens to coincide with alpha bar of 1 plus t by 2. So it's actually going to match on this right hand point, and we are going to actually get a continuous function by gluing lemma. Okay, and so this is also alpha bar of s. And if t is 0, then we just get, so this gives a homotopy between alpha star alpha bar and on top EP. Okay, and finally, in the same spirit as before, we have associativity. Here we have more curves, so let me just write it and we'll clarify the statement. Alpha star beta star gamma is homotopic to alpha star beta star gamma. And here we have a space. Let me take a torus for a change. Then I have P, I have Q, and I have R here. And alpha may be this loopy curve, beta may be this loopy curve. And I need another curve gamma. Okay, so in general I have three curves. I want to say alpha star beta star gamma is alpha star beta star gamma. Let's take a slightly bigger picture this time because it's a bit more complicated. So here goes, here's a square. Okay, and let's recall first, before drawing our squares, what are the quantities we have. So we split at half, and below we just have gamma here, and above we have alpha here. But then we further split into alpha and beta, and here we split into beta and gamma. Okay, so of course the lines we would want is one connecting this to this and this to this. Okay, so again following the same terminology as last time, if you look at the middle portion, beta, let's have it in blue here, beta always goes at 4 times the speed. The gap between these two is the same. It's always a quarter. Alpha starts at 4 times the speed and slows down to going at half the speed. Okay, and it's between this region and this region. Let's give it a different color. Purple between this region and this region, and perhaps gamma is going to be orange between this region and this region. Okay, and let's get some equations. Now I'm going to just do it by inspection. I've got used to it from the previous 2 examples. Hopefully all of you have too. So this starts at quarter and goes up to half. Okay, so it's sort of like the previous curve except it's scaled down. So this curve here, let's check, is as far as I can see, it's 1 plus t divided by 4. Okay, so let's check. So at t equals 0, this is quarter. At t equals 1, this is 1 plus 1, 2 by 4, which is half. And it's correct at 2 points means it's correct. Now this is a quarter shifted from this. So this is going to be s equals now 2 plus t by 4. The 4 remains. The slope is the same. Let's check again. at t equals s equals t equals 0, this is just going 2 by 4, which is half, and at s equals 1, this is 3 by 4, 3/4, which is what you want. It's half plus a quarter. Okay, so this tells us what the regions of our homotopy are. So homotopy is given by, let's be a little generous in space, h of st. Okay, I'm not verifying in these videos what is that these actually satisfy the condition. For a formal proof, you should also verify that at the bottom it gives you alpha star beta, at the top it gives you that. Those are quite routine calculations. Okay, so I'm focusing on how you come up with the correct homotopy. You have to check continuity by checking that they match, and you have to check that it indeed starts and ends at the correct quantities. Okay, so homotopy h of st is given by, let's break it up into 3 regions, and the regions here, the first one is going to be 0 is less than s is less than or equal to 1 plus t by 4. This is going to be the easiest formula, and then there's going to be 1 plus t by 4 is less than s is less than or equal to 2 plus t by 4, and then finally 2 plus t by 4 is less than or equal to s is less than or equal to 1. Okay, in this region it's alpha of something or the other, and it starts at 0, so there's no need of having an offset. You just have to take the scale, and the speed is of course the reciprocal of this length, 4 into 1 plus t, and multiplied by s, 4s by 1 plus t. So you immediately check at 0 it is alpha of 0, and at this point it's alpha of 1, which is what we wanted. Okay, and at the base, so it's automatically alpha at the base. Okay, and how about beta? It's going to be beta of something. Speed is 4, but the offset, so you're going to get beta of, so in this region I'm going to look at s minus the left end point. Okay, so that left end point is 1 plus t by 4. Okay, but I'm going to multiply the whole thing by 4 because that is the speed, so it's beta of this guy. So let's simplify this a little. So this is beta of 4s, the 4's cancel, minus 1 minus t. Okay, so let's put it as 4s minus 1 minus t. Gamma is the worst case because it has both a speed and an offset. The speed is the length of this character, which we have not yet calculated. So it starts at half. So what is the length of this orange guy here? Let's look at its length. So this is going to be 1 minus the left end point, and the left end point is 2 plus t by 4, which is going to be 4 minus 2 plus t by 4, which is 2 minus t by 4. You might have guessed this just by having the fact that it's by just mirroring the thing. 2 plus t by 4, it becomes 2 minus t by 4. Okay, so the length is going to be 2 minus t by 4. So the speed is going to be the reciprocal of this. So we are going to get gamma of, first of all, 4 by 2 minus t, and then s minus the left end point, and the left end point is going to be t plus 2 divided by 4. Okay, and so 4's go away, so this is going to be gamma of, well, we're going to get 4s minus t minus 2 and divided by 2 minus t. Okay, now you have to check if there are tiny errors in these formulas. You may have to correct them. Did I get that? But hopefully there aren't. But as I said, the principle is easy. 4s minus t minus 2 by 2 minus t. Okay, maybe it's worth verifying in this case, since this is our last one. What happens when t equals 0? Here you'll get alpha of 4s by t is 0, which is for alpha of 4s between 0 and 1 by 4, which is indeed what you have. And then here you'll get beta of 4s minus 1 between 1 by 4 and half, which is exactly what you want again for this stretch. You're going at speed 4s up to half. Okay, but at quarter you want to be at 0, and finally you'll get gamma of 4s minus 2 by 2, which is just 2s minus 1, which was gamma of 2s minus 1 was what we got in the, so we got beta of 2s minus 1 when we just looked at alpha star beta formula. Okay, so it's really the same thing that we had in that case. Similarly, you can verify on the top that you get alpha star beta star gamma. Okay, so this was a little bit of work that we had to do, but what it showed us was that the star, E and bar behave as good algebraic operations must behave up to homotopy, so that if we, for example, quotient by homotopy, we'll actually get associative products, inverses, and some sorts of identities. Okay, not literally the group identities, but by specializing to a base point, we do get actually the group identities. In general, you can say slightly better than the group identities.